or not. Okay, so let me make this first 2029, then I will discuss about 2028. Okay. So how do I check whether a large number is given to you whenever you are having a larger number, whether it's a prime number or not? You will check up to where? Up to its square root you will try to check, right? Okay. So is it prime or not? Hmm? So question is now, is 2029 a prime number or not? First of all, you have to figure it out. Positive. Prime or composite? It's a composite number. What are factors? So how do you check for prime number when a large number is given to you? Obviously, I can't list all the prime numbers up to 2029 and check it, right? So what is the trick you will do? Yeah, because you will find the nearest square root to 2029. Okay, you will check up to that part, right? So 2029, what is the nearest square root, sir? 2025 square is going to be 2025, right? Sorry, 45 square is going to be 2025. So whenever a number 2029 is there to you, so 2029, if I am seeing, is it prime or not? To check that, what I'll do is I'll just check for 2029. The root over 2029 is approximately something like 45 plus, because 45 square itself is 2025. So you just find the square root of that number. Now find prime numbers up to 45 and see whether is that number divisible by any of that number or not. If it's divisible by any of the prime number, then it is going to be composite, else it will be a prime number. Now just enlist all that and check it out once. So that is what you have to do. You have to enlist and check it out. No other alternative. Now check and let me know whether it's prime or composite number. So you will be checking obviously for 2, 3. Here it is easier to find out 5, 7, 11. 37 is a prime. 39 no. 41, 40. You have to check for each of this. 2 easily, like, yeah, you say me no. It's a prime. So it's a prime, then it's easy to solve it, right? Actually, it's a prime number. 2029 is a prime number. So it's a prime number means you'll be getting here now. When you're trying to solve it, it is not divisible by any of this actually. If you check for each and every number, it will not be divisible by any of this. So you can say it's a prime number. If it is divisible by any of the primes, obviously you can express it as product of two factors. It will become a composite number, right? Now if I go back to that question now, 1 by x plus 1 by y is equal to, again you're having, if I give you 1 by 2029, then how do you do it, sir? I'll be having here now x minus, when I do forceful factorization, I'll get x minus n into y minus n is equal to, you're getting it as what, sir? 2029 whole square. Okay. Now again I have to split into product of two factors. So how do I split this into product of two factors? One way is 1 into 2029 whole square only I can write it out. Or other I can do is, I can add as 2029 into 2029 should I count 2029 whole square into 1 also as one way? Because here you are just equating the first factor to first number, right? So I have to write the other thing also, right? So 2029 whole square into 1. Same way I can also do it for negative numbers, right? You'll get negative 1 into negative of 2029 whole square. You'll get 3 more negative numbers. So for first number you're adding 2029, second number also you're adding 2029. So total again how many integral solutions I'm going to get? 6. So it's a prime number, it's easy to figure it out. Because when you're having a perfect square of prime, you can resolve it into product of two numbers in only 3 ways. Okay, if p is a prime number, p square can be written as 1 into p square, p into p, or p square into 1. 3 ways only you can resolve it, isn't it? But what if it's a composite number? Then if it's a 20, yes, it's a positive. If it's a composite number, then first you have to find all the positive factors, and there is a formula for number of divisors. Okay, so do you remember any formula for number of divisors or factors after prime factorization? Yes, yes. A plus 1 into b plus 1 into c plus 1. Yeah, you'll get a formula like that. Okay, fine. For now, this is enough for you. Okay, is it okay? Chalo. Similar pattern, I'll give you one more question. You try the other question is, yeah, instead of this, if you're having a question like this, 1 by x plus 2 by y is equal to 1 by 4. Find the number of, here I'm asking only about positive integral solutions. Positive integral solutions. Right, keep trying. How many? 12. Positive, yeah. What is the answer? You're getting 6, sir. You try the other question. Anyway. What is the answer you're getting for this? 6. Oh, that's a good thing. Yeah, yeah. Correct, 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 correct. There's one small thing I missed in the last question. Where is this question? Yeah. When I'm trying to see, because whenever you're having 1 by x plus 1 by y, no, this question it's fine, okay. So here it is fine. But when you have here 1 by x plus 1 by y, where is this question? Yeah. Whenever n is becoming equal to 3, the equation itself is having 1 by x plus 1 by y, right? So can the denominator be equal to 0? Xy cannot be equal to 0, right? So I have to see whether you are getting any value where x or y are becoming 0. If I'm looking into this here, so I'm getting a scenario in this particular case. What do I get, sir, here now? I'll get a case where x minus 3 is equal to minus 3 means you'll get a case where x and y both are becoming zeros, right? So I can't include this. So any other case will you get x and y both as zeros? No. Because simply I'm adding both 3's over here, 3 over here. Here also I'm adding 3 and 3. So that means this one case I will not include here. So this answer is going to be here 5, sir, not 6. Answer will be 6 for this particular equation. Okay, here x and y can be zeros, not a problem. But in the original given question, x and y can't be 0, right? Okay, so here in this case, answer is going to be 5. Okay, be careful with this. Okay, good. So here also, actually, if you look into it, when you're factorizing, if they're asking you integral solutions, I'll get minus 20 into minus 20. There also I'll get x and y as both as zeros, right? So here also you'll get answer as what? 5 only in this case. If they're asking you number of integral solutions, it has to be 5. So here also try to factorize it. So if you cross multiply and look into it, what did I get here, sir? Here I will be getting y plus 2x times of 4 is equal to xy, or you'll be having it as 8x plus 4y minus xy is equal to 0. Or if I'm taking x common from first and last terms, you're having it as x times of 8 minus y plus 4y is equal to 0. Now to factorize it, what I should do here now? If I take 4 common, I'll get y, but I want 8 also. So I'll add and subtract 32. If I'm adding and subtracting 32, so can I add as x into 8 minus y plus 4 into I'll add as y minus 8. I'm getting 4y minus 32, so I'm also adding 32. So I can add it as again, I'll take y minus 8 common, or if I take y minus 8 common, then I'll be having 1 minus 8 into minus x plus 4. I'll take 32 to the other side, it will be minus 32. Now I can write down this equation as, if I multiply with negative signs, it will become to me now x minus 4 into y minus 8 is 32. Now try to split this 32 into product of two factors. So how do I split this 32 into product of two factors? Again, you can start writing all things. So 132 to 16s, right? 8 fours, 8 into 4, 16 into 2, 32 into 1. I'm not taking negative things. Okay, they're only asking about positive integral solutions. If x and y both are positive means, so even if you're considering negative factors, like should I consider negative factors? What do you think? Okay, because you'll be getting negative solutions. No need to consider it now. Add 4 to x and add 8 to the next thing. Then you'll be getting positive integral solutions. So what is the answer I'll be getting here, sir? 6. Is it fine? Okay. Are you missing any factor? Yes, correct. What happened, Anshu? No, no, because if I'm seeing negative part, so what are the negatives you'll be having here, sir? I'll be having minus 1 into minus 32, minus 2 into minus 16, minus 4 into minus 8, minus 16 into minus 2, and again you're also having minus 32 into minus 1. So whenever x is a negative number, if x is a negative integer, if I'm trying to take it, we just add x4 to it. Okay, if you just add for the first number 4, so the last 3 will automatically get rejected. Okay, so first 3 solutions x is going to be positive, but what will happen for the other part? So here you will be getting y as 0, but I can't take y as 0, and in the remaining 2 cases I get y as negative only, no? So I will not have any solution in this case, right? Is it fine? Chalo. the answer. A to the power 5. The question says to you here you're having some A, B, C, D are positive integers. A power 5 is B power 4. C cube is D square. C minus A is 19. A, B, C, D are positive integers. Positive. Then find D minus B there as so how do I start in this question? Any ideas? Hmm? What about? Come again. Logarithms you're thinking about it. Okay, fine. Others, any other approach? There, Sudan, Sudanwa. What is the thought process you're getting for this question? Because they're trying to say A, B, C, D all are integers, and fifth power of one integer has to be equal to the same number should also be expressed as fourth power of another integer. So, are you getting any hint from this particular statement? Fifth power of one number should also be at the same time fourth power of some other number. So, how does that number look like now? Because in that number, so that has to be something in the form, some, I can say now here a power 5, b power 4 will be equal to something like some k1 to the power 20. Okay. You can think in this way. For example, if I say randomly if I take a as 2 square, no, or let me take a as 2 power 4. Okay, so 2 to the power 4 whole to the power 5. You will be writing it as 2 power 5 whole to the power 4. Right, so that means definitely I should get that in that number. There will be some base in the exponent what I should have. Power 20 I should have, right? What do you say? Right? It's fine. Because where again here again k1 is some integer. Okay, so in that case itself what is going to happen is you are writing that same number as now k1 to the power 4 and b is going to become to you k1 to the power 5. So I can come to a conclusion here now. Number a is going to be to you k1 to the power 4 and at the same time number b is going to be k1 to the power 5. So you can see here now k1 power 4 whole power 5, k1 power 20 is same as k1 power 5 whole power 4, 20. In the same way what I can say now here, so by looking into this, there should be a number whose power 3 should be same as square of some other number. So how should that number look like to me now? So if it's only, for example, if c is only a prime number, no, so I will not get again power 2, right? So definitely in that number there should be power 3 as well as power 2. So that means can I say this number will be something in the form some other number k2 to the power 6? Can I say it can be anything? I mean k2 can again be some perfect square. It can give you power 12 also again, right? So but this is the bare minimum thing. Can I say it? That means what I can say about number c now here, sir. Number c looks like to what? It is k2 to the power 6 by 3 again. It is k2 square. And number d looks like to what? K2. Right. So you reach up to here, then what I can say in this part. So now only two unknowns are there. Basically, if you see these two questions, these two equations, this seems to be like four unknowns. Now what has happened here now? There are only two unknowns. A is in terms of k1, B is also in terms of k1, C in terms of k2, and D in terms of k2. There are only two unknowns, and another equation is given to you. C minus A is 19. So since you know C minus A is 19, so what is C to you here, sir? It is k2 square minus A is again what? K1 to the power 4 is 19. C minus A, no? C minus A is 19. So what is A here? 20 by 5, no? 4, right? So I am having k2 square minus k1 power 4 equal to 19. I have to solve this equation. Again, how do I solve this equation? Because these are perfect squares, can I factorize it? How do I factorize it, sir? Can I write as k2 plus k1 square into k2 minus k1 square is equal to 19? What are k1 and k2? Are they going to be again some integers only or not? That means this is an integer, this is an integer. You are trying to write the LHS as product of two integers. So how do I get it? RHS also have to split into product of two integers. Is it fine? So I'll just write 19 as product of two integers. So how do I write it as, sir? I can add 19 into 1, or also I can add as what? 1 into 19. Should I go for negative part? I will not take negative because they're already saying A, B, C, D are positive integers, right? Or okay, even if I consider negative also, then what is the 4 cases you'll get, sir? You know, I can write this part as, now you will get total 4 scenarios. So one scenario says to k2 plus k1 square is equal to 19, and at the same time I'll have k2 minus k1 square is equal to what? 1. Another scenario I'll be having it as k2 plus k1 square is equal to 1 and k2 minus k1 square is equal to 19. And the same thing you'll have minus 19 minus 1, minus 1 minus 19. Now I have to try to solve this part. So how do I solve this again? So Again, I know k2, k1 are integers, right? So I'll just try to find first k1 square. If I subtract these two, what I'm getting, sir? I'm getting 2 times of k1 square is 18. So you're getting value of k1 square as 18 by 2, 9. So k1 can be actually what? Plus or minus 3. Is it fine? Plus 1, plus 1. Because I can factor 19 as what? Either 19 into 1, 1 into 19, or negative factors also you can take minus 19 into minus 1, minus 1 into minus 19. So k2 minus k1 square is 1. And if you try to simplify this value, so what is the answer you'll get? Add these two, you're getting 2k2 as 10. Or I can say k2 value is, sorry, 20 by 2 is 10. Right? So 2k2 is 20. So 20 by 2 is 10. If k2 is 10, then k1 I will get as what here, sir? I can get as plus or minus 3. And if you look into other scenario, it's again same thing. Okay, so k2 is, if you look here, if you're adding again, you're getting 2k2 is 20. So you're getting here k2 value is 10, but here will you have solution? K2 is 10, but k1 square is becoming minus 9. So do you have any solution over here? No solution. You can think in this way itself. If I take minus 19 minus 1, no. If I'm adding the two equations, I will get k2 as what, sir? Minus 10 I will get. If I'm substituting k2 as minus 10, so k1 square will become what to you? 29. So it's not any perfect square, right? So you can neglect that. If I take minus 1 minus 19, if I take minus 1 minus 19, then still again k2 is still what? Minus 10. So k2 is minus 10. So k1 again you'll get us what in that case? Plus or minus 3. You can also take the negative scenarios. If I'm taking negative scenarios, k2 plus k1 square is equal to minus 1. k2 minus k1 square is equal to minus 19. And if I'm trying to solve these two, you're getting the value of k2 as minus 10, and I'm getting k1 as plus or minus 3. Right? Whereas if you take the other scenario, which is minus 19 and minus 1, you will not have any solution, right? Other scenario, the last scenario will not have any solution. So these are the solutions you're getting now. Now once you get this solution, I can find the value of, they're asking you to find now d minus b. So what is d minus b going to be, sir, here now? So your final answer is d minus b. Now again, one more thing I will say is, because I know here a and b are positive integers, can I take k1 as negative 3? They're trying to say in the question a, b, c, d are positive integers. If I take k1 as minus 3, no, it is not going to work out. I have to take only plus 3. So d minus b is something in the form to, it is k2 cube minus k1 power 5. So since, so if I take this as a scenario, okay, so if I take 10 comma plus or minus 3 as a scenario, then I'll be getting k2 cube as what, sir? I'll get 10 cube minus of, so k1 to the power 5, I'll get as 3 power 5. Okay, so why I'm not taking k1 as negative is, the reason is b has to be positive integer. And if you're taking the other scenario also, if I take k2 as minus 10, so still in that case, k2 if I take it as minus 10, this is fine. But k1 plus 3, so what I want, what are the final possible solution sets of this part? Okay, so before going to the final answer, let me do one thing. I'll write first, since a, b, c, d, so these are actually positive integers. These belongs to positive integers. I can say now here k1 comma k2. They can take the values of 3, 10. Okay, so minus 3, 10, I'm going to reject it. And if you see here, 3 minus 10, can I take it? Can I take it as k1 as 3 and k2 as minus 10? No, because if I take k2 as minus 10, this again not working out, right? So k2 minus 10 is going to get rejected. Right. So once you got this, then you're just trying to find d minus b. So d minus b is going to be, d is k2 cube, which is 10 cube, minus, what is the value of a, sir? K1 power 4, which is 3 power 4. Got the idea? What is your approach? You done the same way? So these are something which are like purely number theory based questions, right? So as I told, like we have not started the 11 JE part. Okay, so these are but still helpful to you in solving some of the JE mains and advanced type of questions also. This concepts keeps coming. Okay, it okay? Now let us try this particular question. If m comma n are natural numbers and m is in this format, then find mn values. Yeah, it is n minus 4. Not m, it is n. Okay. N square minus n minus 35 by n minus 4. Okay. Because numerator is a quadratic in n, denominator is also quadratic in n. Sorry, it's a linear in terms of n. Now division of these two is giving you m. Mn has to be natural numbers. They're asking you to find that value. So how do I start it? For example, if I say, so forget about this. For example, if you're having something in this way, if I say something like this, if you're having 4 by n minus 4 should belong to natural number. When is it possible? N minus 4 has to be a factor of 4. Okay, since I'm saying natural number, it has to be a positive factor of 4. So n minus 4 can be 1, it can be 2, it can be 4 in this scenario, right? So n minus 4 in this particular scenario can actually take value of 1, 2, 4. If they're saying it has to become some integer, then it can be plus or minus 1, plus or minus 2, plus or minus 4. But here the thing is, you have n square minus n minus 35 by n minus 4. If you try to factorize also, the numerator is not having factors. I can think about the last term. 35 by n minus 4 can be done easily. Okay, same logic again. I will try to bring the denominator factor in numerator. So how do I bring n minus 4 in numerator? How do you express that numerator in terms of n minus 4 into something? Because factor is not there, okay? So it's not Is n minus 4 a factor of this? If you're replacing n with 4, so I am getting 16 minus 4, which is 12 minus 35, which is not equal to 0, right? If that was 0, it's a factor of 4. N minus 4 is a factor. So how do I get, I want to express this numerator as n minus 4 into something, then again some remainder is left over, right? So basically what you do is try to divide this numerator with the denominator part. If I am trying to divide the numerator with the denominator, then what I'll get here, sir? I'll be having here now n square minus n minus 35. I'll do one thing, I'll simply divide with n minus 4. And if I look into it, the quotient part, if you look, I'll get here n square minus 4n. And if I'm subtracting these two, then you'll be getting it as 3n minus 35. So I can get as plus 3. So 3n minus 12. Again, if I subtract these two, I'll be getting it as minus 23, right? So you can see I can write down this particular numerator when I'm trying to divide with n minus 4. So using the division algorithm or Euclid's lemma, I can say it as something in the form of n minus 4 into n plus 3 minus 23. Can I say? Is it okay? Now when I try to rewrite this question now, so what is m going to be in this case, sir? Now here I'm dividing it with n minus 4. So when I divide with n minus 4, so quotient is 2 n plus 3. So I'll get n plus 3 minus of 23 divided by n minus 4. This is how the question looks like, right? Now it is something which is similar to this concept, because I have to make m and n both natural numbers. So since m comma n both belongs to natural numbers, now this first part is anyhow going to be a natural number. So this first part, if I look into it, n plus 3. So whenever n becomes natural number, this will always be natural number. Now only thing what I have to do is first, this should not look like this should not become a fraction to me first of all. So unless and until I have in denominator some number, okay, if it's becoming some proper fraction, it will not never become a natural number. So for m to be natural number, the first condition I would like is I would like to impose is what, sir? For m to be natural number, so first of all, this n minus 4 should become a factor of 23, right? Agree? Is it fine? Anshu? So n minus 4 should become factor of 23. So what are the factors of 23 you're having? So you can have, I'll take all the factors, positive factors, negative factors also, because it's actually minus 23, the number is. So what are the factors of 23 you're having? I can add as 1 into 23, or I can add as minus 1 into minus 23. Okay, now I'll start looking into the conditions. So for example, if I say here, I'm getting value of n as what, sir? I'm getting 5. You add 4 to it, you'll get 27. 4 minus 1, 3. Again 4 minus 23, I'm getting what? Minus 19. So these are the values of n for which this particular term. Okay, so this particular term denominator is not going to be there. It is going to be some integer, right? Now I have to make natural number. So what is the value of m? In this scenario, if I look into it, so what is the value of m you're getting, sir? It is n plus 3 minus this, right? So 5 plus 3, 8. 8 minus 5. So you're getting it as 3. If I take n as 27, so 27 plus 3, I'm getting 30. 30 minus, wait a minute, I think when you're trying to take n as 5, so what is the value of m you're getting, sir? I'm getting 5 plus 3, 8. 8 minus 23 divided by 5 minus 4 is 1. No, so m is becoming a negative number, isn't it? So since m is becoming a negative number, will I consider it? So I will not consider it. So when I'm trying to take n as 27, so when I take n as 27, what is the value of m you're getting, sir? Here I'm getting something like 27 plus 3, 30 minus 23 divided by 27 minus 4, which is again 23, which is 30 minus 1, which is 29. I can consider this. When I take n as 3, so what is the value of m you're getting, sir? 3 plus 3, 6 minus 23 divided by 3 minus 4. So 3 minus 4 is again minus 1. So this gives me m value as what? 29. So m 29, n 27, 3 are valid. And if I see the last scenario, when I take n as minus 29, so what is the value of m you're getting? Minus 19 plus 3, which is minus 16, minus 23 by minus 19 minus 4 is again minus 23. So I'll have minus 15. So since they're asking you natural numbers, so therefore I can say m comma n values are what, sir? 1 is 29, n is 27, and another thing I will take is 29, 3. And look into the question now. In the question, what are you having here? You're having n minus 4. Am I getting anywhere n is equal to 4 as a value here? I am not getting. If you're getting anywhere n is equal to 4, I cannot take it. Right? Is it fine? Got it? Okay, so similar pattern, one more question I'll give it to you. Try it once. Find all pairs of positive integers n comma m such that for the first time if you're seeing these type of questions, you might be feeling a bit difficult, okay? But don't worry, like as you keep approaching the questions, it is going to be easy for you, right? For the beginning, if you're encountering this question for the first time, getting this idea is really difficult, okay? So how do I get the idea? Like I have to express it as divisor into quotient plus remainder. That is a bit difficult, but if you have solved one, two questions, then when you see the third question or fourth question, you'll be automatically getting the idea. Okay. So anything like this, okay. So these are purely number theory based questions, right? So this also, when you look into this question first, so starting first time if you try to solve it, it is difficult. But if you have solved one, two questions, now you are getting another question in the pattern, you should be able to solve it easily, right? So because as I told, for the first week in max, what we'll be doing is we'll be seeing some questions which will be of IOQM level, okay, which are of which can be relatable to your 10th standard, but still you'll be getting these type of things in your JE advanced preparation. From next week, we'll start the original basic max, which is required for JE mains and advanced. What is the idea you're getting here? One thing I can say is they are saying integers, so one side I am having a perfect square, which is m square. Do you have any perfect square in the same equation? Any other perfect square are you able to see? Yeah, 4 is another perfect square, 2 square. So you can write down this as something in the form 2 power 2 whole power n plus 260 is equal to m square. I'll take both the perfect square terms to one side. If I'm taking it to one side, then what I'll have, sir, here? I'll have m square minus of, can I write down this thing like this? 2 power n whole square. 2 to the power 2n only, no? So I can write as 2 power n whole square is equal to, again, what you're having? 260. Now you get the idea. So I'm getting a square minus b square format. If you're having a square minus b square, what I can do? I can write as a plus b, which is m plus 2 to the power n into a minus, which is m minus 2 to the power n. So again, whenever m and n are integers, these are also like two integers only. So I will try to express the RHS as product of two integers. Okay, so 260 is a composite number. Now start expressing it as a product of two integers. And if you basically observe which is the largest integer among this, they are positive integers, no? So first is the highest integer. So I will not go with, I will go with this thing. First of all, I'll write as, I'll start writing into the highest integer first. So 260 into 1 I can go for. Then 130 into 2. Then again another 2 I will take to other side. So I'll have 65 into 4. So 13 into 5, right? 13, 5, 65. Then again I'll keep 113 over here. If I take 5 other side, it will become 20, right? So 20, I'm writing, wantedly I'm writing in the starting place higher number because I know m plus 2 power n is larger than m minus 2 power n. Are you missing anything? All the factors are came here. 52 into, okay. So again I'll split this again as 10 into 2. So I'll get, when I'm splitting it into 10 into 2, then I'll be getting here two more factors as 10 into 26. So I can add as 26 into 10. And if I write only 5 over here, 5 into 4. So 65 into 65, right? Yeah, 65 into 4. Yeah, I already done it. Sorry, my bad. Yes. So 130, I'm writing it as 65 into 2. This again 13 into 5. So 1 and 5 I have taken. That's it, right? 52 into 52 into 5. Yeah, correct. Again, this 10 if you split into 5 into 2, then you'll get 52 into 5. Correct. And right here itself, 52 into 5. Now again think one more thing. So total how many cases I'm getting here? 1, 2, 3, 4, 5, 6. Before starting, before solving this case, look into it. If I add these two factors, what am I going to get, sir? If I am adding these two factors, 2m, which is a even number. If I subtract the two factors, I am getting 2 times of 2 power n, which is even number. So addition of factors and subtraction of factors is giving you even number. Means how should the factors look like to you? Either both should be even or odd. That only will give you solution. Is it understood? So if I take for example 261, no, one is even, one is odd, I will not get a solution. The reason is when I am adding these two things, no, when I add these two things, I will get 2m is equal to 261. So I am not getting m as an integer, right? Again. So only even, odd combination only is going to give you solution. So you only search for that. So I will not search for this. So this is not going to give me a solution. Whereas if I look into it, this is looking like to me even. So this will give me a solution. Okay, so even will give me a solution. Then odd, this also will give me a solution. Which one? Achha, sorry. Last one is not going to give a solution. You are having odd and even again. So even odd is there, that's not going to give a solution. This if you look into it again, you have again a even odd, not solution, no solution. So I'm getting two scenarios. So try to solve these two scenarios. So I'll take now first scenarios. Case 1, I'll write m plus 2 to the power n as 130, m minus 2 to the power n as 2. And if I attempt to solve these things, so you're getting 2m as 132. or you're getting the value of m as what, sir? 132 by 2, which is, right, you're getting 132 by 2, which happens to be 66. So m is 66, n is 2 power n. 2 power n is, you're getting it as 66 minus 2, which is 64. So 2 power n is 64. That gives you n as how much? 2 power 5 is 32, 2 power 6 is 64. N as. Similarly, I'll look into the next scenario. So case 2, I'll take it as m plus 2 to the power n is something like 26, and we had m minus 2 to the power n is 10. Now if I add these two, I am getting 2m is 36, 36 by 2, 18. So I am getting m value as 18, and if you see carefully, 2 power n is 8, so n is equal to, it's fine. They're asking find all possible integers of m and n. Got the idea? Right? Fine. I think stop it over here. Okay. This particular question which you asked in the beginning. We'll end with this question. So find if a plus b plus c is 0, they're asked you to calculate the value of this. What can be done here? But I know a plus b plus c is 0 means if I try to do some manipulation here, if I square it on both sides, then what do I have here, sir? I'll have a square plus b square plus c square as 2 into sigma ab is equal to 0. But they are having here 2a square plus bc, right? Yeah. Or if I try to convert this only in terms of b and c, I can replace a with minus b minus c, right? I'll get 2b square plus 2c square plus 4bc plus bc, which is 5bc you're getting, right? You're getting something in the form a square divided by, sorry, minus b minus c, so 2b square plus 2c square 5bc. And a is negative of b plus c whole square. Okay. The numerator is something which is looking like to you b plus c whole square. Okay, divide with b plus c whole square also. So, mm. Is any other thing you mentioned about ABC, like ABC or natural numbers or nothing? You are getting okay. Then we will consider as real numbers. It's also not working, right? Yeah. Okay. You got any other hint? Yes, okay. Okay, you have done 2a square as a square plus a square plus bc. Fine. Okay. Okay. So one of the a you are writing it as fine minus b minus c. this will make your, I'm getting a square divided by then a square minus ab minus bc minus ac. Is going plus bc. Okay, yeah, it is plus bc. Then you're trying to factor it. A into you're getting a minus b plus c into a minus b. Okay, fine. So if I try to factorize here, so I can get a factor over here as a times of a minus b. Fine. Here you're going to get as c times of b minus a, right? So I can take a minus b common. So you're getting the factors as a square by. If I take a factor a minus b common, then it is fine. So if I take a factor a minus b common, then I'll get a square by a minus b into a minus a, right? Is it okay? Now I'm getting the first term as a square by a minus b into a minus c. So once if you're getting this factor common, now replicate the same thing in the next three terms. Good idea. So I'll write down this question as no a square by a minus b into a minus c plus the next term also will be getting same format b square by b minus c into you should get b minus a, and the last time you should be getting something in the format of c square divided by t minus a into c minus b. Okay, so if I try to take the LCM, okay, so you will be getting a minus b, b minus c, c minus a as the LCM. Now multiply the remaining thing. Okay, and if you are getting anywhere a cube plus b cube plus c cube, use it as 3ab's. You are not getting anything with it. Okay. After LCM, terms are getting cancelled away. Is it like that? Numerator also you are trying to find. Okay. Numerator also you are writing a square as a into a, isn't it? You get like this. I think maybe have you gone with the LCM over here? Like if I just take the LCM over a minus b, b minus c, c minus a, the terms you're getting it. I think taking LCM and expanding here also should use the answer. Okay. Or what is the idea you got? What is the idea you used? Taking LCM on that. Okay, so I'll give you one, two more questions. You try those questions once. Product of three prime numbers is 5 times sum of these prime numbers. And the product is divisible by 5. And the product is divisible by 5. Find these numbers. Hmm? Hmm. It is 5 times this. Yeah, it's already divisible by 5. But I'm trying to say product of these three prime numbers. There's also one more part over here. Three prime numbers product is divisible by 5. Means the hint over there says that definitely one of the prime number also has to be 5, no? Yeah. It is obvious. Like if I say product of three prime numbers is 5 times, then it is definitely divisible by 5. Correct. Ordered triplets. Find all ordered triplets A comma B comma C, or order triplets of prime numbers. Okay, so here A, B, C are prime numbers. Such that 175A plus 11AB plus BC is equal to ABC. The question is, solve A plus B plus C, 2AB 4ABC is equal to 2017. So it is given to you here again, ABC belongs to positive integers and A greater than or equal to B greater than or equal to C. No, because see, if I say product of three number is 5 times, for example, if I say that actually they have mentioned prime numbers, fine. So P1, P2, P3, it is becoming some 5 times of P1 plus P2 plus P3. That is what is the question, right? Yeah. Product is obviously divisible by 5. Yeah. That is evident actually. If they are trying to say product of three prime numbers is 5 times the sum of that, product will be definitely divisible by 5. Fine. Try these questions. Tomorrow's class, we'll discuss this and we'll see a little bit more extension of these type of questions. Okay.